Hello! What we're going to do right now is actually going to visualize the average rate of change of a function. So let's say you have a function. In this case, our function is f of x equals x times sine of x. So it's an algebra function times a sinusoidal function. And notice there is some oscillating motion going on, but we're particularly interested when x equals 2. So here's the x-axis, and our point of interest is going to be at x equals 2. And we're going to first approach x from the right-hand side. So I'm going to take a second point on the function. That's going to be called b f of b. And our point of interest is actually going to be at a equals 2 here. And so there's a equals 2, and then that will be f of 2. So we can see that down here. A is actually 2, and then f of 2 is actually this output right there. So as 4.2 is going to approach the number 2, so x here is 4.2, and we're going to go ahead and start approaching x equals 2 from the right. So as you do this, you could actually calculate the slope between 2 points. And our second point is always changing, so our average rate of change for that function is always changing. The average rate of change is actually computed by finding the slope of this secant line. A secant line actually goes through the function at 2 points, and we're just computing the average rate of change. Once again, that average rate of change is actually the slope of this secant line right here. It's going right through there. And then we're going to keep approaching 2 from the right until we get very, very close to it. And once we get very, very close to 2, we're almost at what we say an instantaneous rate of change. So notice this is 2 6/100ths, and now we have 2 here. A is 2. Let's see how close we can get it. And pay attention to the slope of the secant line. So now I'm at 2 3/100ths. I'm only 3/100ths of away from x equals 2. Now I'm even 1/100th of away. 1/100th from 2 on the right hand side. And notice the slope of the secant line is about 6/100ths. Now we could also approach x equals 2 from the left hand side. Notice we'll get secant lines over here. Once again, remember, a secant line is actually a line that crosses through the function at 2 points, and the point of interest is actually x equals 2. This time I'm actually on the left side of 2, and now we're going to approach x equals 2 from the left side. So notice we're starting at -1 54/100ths. We're going to start moving towards the number 2 from the left hand side. Notice the slope of the secant line keeps changing. It keeps changing, it keeps changing, it's still changing. And then as I get closer and closer to 2, I'm getting very close to an interesting moment. Getting very close. I'm at 1 84/100ths. Let's get closer. Closer, closer. I'm at 1 96/100ths. I'm pretty close. Let's see how close I can get. Oh, too close. Oh, let's see. I think it's going to be 1 96/100ths. Oh, I got 1 98/100ths. And notice I'm very close to 2 from the left hand side. And let's look at the slope of the secant line. This is at 1/10, about 1/10. From the right hand side, we got as close as 6/100ths. So if I had to guess the slope of the tangent line, the slope of the tangent line is at the moment of x equals 2. If I had to guess the slope of the tangent line, what's the average between 6/10ths and 6/100ths and 1/10? I would guess about 8/100ths. So let's see the tangent line. There it is. That is not the average rate of change anymore. That is the instantaneous rate of change at the instance or at the moment of x equals 2. And if I had to guess the slope of this tangent line, I would guess 8/100ths, positive 8/100ths. So once again, we could approach x equals 2 from the right hand side, and we could see the average rate of change. And then when we get to the positive 2, when we get x equals 2, we actually could see the instantaneous rate of change, which is the slope of the tangent line right there. And we can also do this again from the left-hand side. As we approach x equals 2 from the left-hand side, we can see the average rate of change. It keeps changing, it keeps changing. You can compute all those slopes of the average rate of change. But at the moment of x equals 2, we'll get what we call the instantaneous rate of change, which is the slope of that tangent line.